Welcome to another one of my videos in this Euclidean geometry series. And as always, before we get started, I'll give you an opportunity to read the question, pause the video, attempt it, and then once you're finished, you can play back the video just to check how you've managed to get on with the question and compare your solution against mine. So I'll give you a couple of seconds to pause it and read through the question. Okay, so let's dive right into the question. It says, in the diagram, O is the center of the circle and CG is a tangent to the circle at G. The straight line from C passing through O cuts the circle at A and B. Diameter D or E is perpendicular to CA. GE and CA intersect at F. Chords DG, BG, and AG are drawn. So the first part of the question is that we have to prove that DGFO is a cyclic quadrilateral. So I often take my highlighter to highlight the points that or the shape that I'm required to prove. So in this case, I have to prove that DGFO is a cyclic quadrilateral. So you need to be aware what is required when we prove that a shape is cyclic quadrilateral is a cyclic quadrilateral. So what it simply means is that it's possible for me to draw a circle around these points here, and that shape is going to be contained in that particular circle. So a shape is cyclic if I can prove that one of the chords subtends angles that are equal, okay, and that would be the converse of angles in the same segment, or I can show that the opposite angles of the given shape will add up to 180. In this case, I could look to determine whether D plus F2 or plus G will give me supplementary angles, either one of those pairs. So I'm going to go ahead and try and do that. I've been given quite a lot of information in this question. I'm told that this is perpendicular, so that's given, but I'm also told that the line DE is the diameter. So it follows that this angle here is going to be equal to 90 degrees. Okay, so have a look here. I'm going to write that G3 plus G4 is going to be equal to 90 degrees, and we will say that's an angle in a semicircle. That's a given theorem. And then I'm going to go ahead and say that the angle O is equal to 90 degrees. And the reason for this is that it's given. Okay. So if I go ahead and say that O plus, you will notice that G3 plus G4 is going to be equal to 90 plus 90. And that's going to give me 180 degrees. Therefore, DGFO is cyclic, and I will have to give a reason for why I'm concluding that it's cyclic, and my reason for that, I will say that this is the converse of the rule that says that opposite angles of a cyclic quad. Okay, so we've managed to solve that first part of the question. I hope you had some success there. Okay, in the second part of this question, we are required to prove that the line GC is equal to CF. So this line GC must equal this line CF. And well, if you have a look here, it's a triangle. It gives us the triangle CGF. And to prove that two lines are equal, we could prove that the base angles are equal to each other. In other words, prove that triangle GCF is isosceles. If I can prove that, then I can conclude that those two lines are equal to each other. In the first part of the question, we've just shown that DGFO is cyclic. So it follows that the angle F1 is going to equal to the angle D. And the reason for this, I'm sure you will agree with me, that this is the exterior angle of a cyclic quad. Okay, if that's the exterior angle of a cyclic quad, it states that this angle here has to equal that. It's the exterior angle. And then the other thing that we could find out is okay, I've got it, that this angle G1 plus G2, you check that angle there, you will notice that, let me use a different colored highlighter here, and let's take this green one. This chord GE subtends the angle D on the other side. You'll see that this chord here GE cuts the circle into two segments. This minor segment, the minor segment GE, and the major segment GE coming around here through A. So it subtends this angle here, and we speak of the tan chord theorem here. So it follows that G1 plus G2 is going to equal D. So let's write here that G1 plus G2 will equal D, and the reason for that is the tan chord theorem. Tan chord theorem. Okay, so with your tan chord theorem, now if D is equal to F and D is also equal to G1 plus G2, it follows therefore that F1 has to equal G1 plus G2. Okay, and so you will notice then that CG must equal G. What did I say? CG must equal CF. That's what we are required to prove. And so I'm saying this because these are sides opposite equal angles in triangle. I'm naming the triangle here just to make it easy for the examiner to follow my argument. And triangle CGF. So those two are going to be equal to each other. I also hope that you managed to get the solution to that one. Okay, for the next set of questions, I'm going to need to make a bit of more space here. So if I scroll down, I've copied the diagram so that there is ease of reference as we proceed with the question. So we are told that it is further given that the line CO is equal to 11 units and DE is equal to 14 units. Now we have to calculate the length of BC. Okay, so that BC is what we're looking for, and we are told that the distance from here to there is going to be equal to 11 units. So you want to think about it like this. So for A, the line CO is going to be equal to 11, but CO is made up of the distance O to B plus then the BC that we're looking for. If you have a look, I've gone from O to B up to that point and then plus the BC that tells us it's C to O. But OB is equal to the radius R of the circle, and it's going to equal to OE, and that's equal to half of this line here, D to E. We are told that this line D to E is equal to 14 units, and we know that it is going to be the diameter because it's also given in the question that DE is the diameter of the circle. So if I know that this OE, or the radius, is equal to half of DE, then that's equal to half of 14. So it follows that OB is equal to 7 units. Okay, so what I'm saying then is 11 is equal to 7 plus BC, and you can see this by inspection then that therefore BC must be equal to 4 units. Okay, so sometimes it helps to put in the information that you've calculated as you go along to ensure that as you answer the subsequent questions, what you've calculated helps you. So I'm going to use a different colored pen for the B part. I know that this BC is equal to 4. Alright, so if BC is equal to 4, so that means the distance from here to there has got to be equal to 7 units. Okay, and so now I need to find the length of CG. Okay, so CG, this length here, that length CG, which we were told is equal to what? To CF. Is that going to be important? Let's find out. What I've gone and done is I've realized that for me to be able to find this, I'll need to identify some similar triangles. So what I've gone and done is I've said that in triangle, the triangle CAG, I'm going to highlight it again. So C to A to G, the triangle there. And this triangle, the triangle CGB, I'm going to use a different colored highlighter, CGB, that smallish triangle there. Okay, I will prove that those two are similar and then use the fact that those two triangles are similar, and when I use the fact that the sides are in proportion, if they're similar, then I'll be able to calculate GC. So let's have a look. C, the angle C, is equal to the angle C because that's a common angle in the two triangles. Okay, remember you need to give a statement and the reason. And then the angle G1 is going to be, this angle here, G1, is going to equal the angle A. Okay, you guessed it right. It's because of the tan chord theorem. You see the tangent there, and the chord that we're given, GB, subtends the angle on the opposite side. So this tangent here, okay, and then there's the chord there. It subtends a different angle, an angle on the other side of the chord, and that's angle A. So the reason here is the tan chord theorem. And then I can show that if those two angles are equal to each other, it follows, therefore, that the angle CAG will be equal to the angle B1. Okay, so this angle I meant that this angle CGA, because we've already proven that G is equal to A. So we want to prove CGA. Let me show you. It's the different angle CGA. That whole angle there must equal B1. Okay. So for that reason, it's because of the interior angles of a triangle. Some people say third angle of a triangle. That also suffices. You can see that this is not drawn to scale, but by inspection you can see that this is actually, it's just an obtuse angle there, and that's also an obtuse angle. So if I make more space here, I want to conclude that therefore triangle CAG has got to be similar to triangle CGB. Okay, now how does this help me to calculate the required length of CG? I can now go on to do this. We're looking for CG. If you allow me to make more space here, I'm going to say CG, I'm starting with the ratio or the side that I'm trying to work out. C to G must over CB, over CB will have to equal CA. Okay, CA is equal to CG over CG, or it's not equal, but it corresponds to CG. And then I will find that AG, the side AG corresponds to the side GB over GB. And the reason for this is because of similar triangles. We've proven that those two triangles are similar. Okay, now this is where it gets very interesting. we are trying to find the length of GC, if you have a look here, or CG. So I have CG in this ratio here, and I also have CG in that ratio. So I'm going to take those two ratios, and if I multiply both sides by CG, I'm going to have CG squared being equal to CA multiplied by CB. I hope you understand what I've done there. I've simply multiplied both sides by, firstly by CG, so that's going to cancel out. Okay, maybe let's do that stepwise. So if we got CG over CB is equal to CA over CG, that's the ratio I'm going to take. So if I multiply both sides by CG, this is going to cancel out to that, and then this one times CG, that's where I'm getting the CG squared over CB is equal to CA, and then I'm going to multiply both sides by CB times this side by CB as well, so that's going to cancel out to that, and then making more space means that your CG squared has to equal CA multiplied by CB. I hope you follow. Okay, but something that we need to realize if we go back to the diagram is that the length C to A, all right, is made up of two lengths. It's made up of the length A to B, which is our diameter. Okay, the diameter is okay, so it's made up of the diameter. So the length CA is equal to, as I was trying to show you here, is made up of A to B, right? That's equal to D to E, the diameter. A to B is 14 units, is equal to AB plus CB, not CB, but BC plus the BC. You see that BC there? Plus BC. So I've just said that AB is equal to 14 units, that's the diameter. BC we calculated in the first part of the question, which is 4 units, so it means that CA is equal to 18 units in total. Okay, so we have that CA. What about the CB? Let's have a look where CB is. So CB is, or BC, but we have that, we have BC. So if you go back here, we also have this one as 4 units. We've proven it. So you're going to say CG squared is going to be equal to 18 multiplied by 4. And so it follows, therefore, that CG is going to be the square root of 18 times 4, which is equal to 6 root 2. Always encourage you to give it in surd form, and then you round it off to approximately 8.5 units to 1 decimal point as required by the examiner in the front page. So that will be the length of CG. Okay, for the next part, or the next part of the question, I will need to make space. Again, I've copied the question or the diagram, and I've just inserted the value of CG that we've been working out in the previous question. So CG is equal to that. We now need to find the size of the angle E. So this angle here is what we require to calculate. Well, you will know that previously we were told that the line CG is equal to the line CF. Okay, so now that is going to be equal to 6 root 2. Well, we're not told this, but we had to prove it. So I can give this as my reason that I've proven it. I'm choosing to work with the surd here because it's more accurate than the rounded off value. So it follows that this distance from here to there is also 6 root 2. Okay, and then we know that this whole distance, O to F, is going to be equal to CF, okay, CF plus OF, that whole distance is equal to that. And so what I'm trying to find is this distance OF here, so that I can make use of trigonometry to find the angle E, because that angle there is going to be equal to 90 degrees, because that's adjacent angles on a straight line. Okay, so that's 90 degrees, and then I will make use of this yellow triangle here to make use of SOHCAHTOA. If you have a look there, I'll have this opposite side, or F, which the opposite side, or F, which I'm trying to calculate by making use of this there. And then I'll also have OE as the radius, and you can see that will be the opposite of the adjacent. Okay, so let's write it down in a manner that will be acceptable to the examiner. So OF is going to be equal to, so CF is equal to, well, here I wanted to say that O to F is going to be equal to this whole distance here, OC. So here, OC minus this distance CF, minus the distance CF. Okay, alternatively, if you want to think about it this way, you could say that the distance O to C is equal to the distance O to F, okay, plus the distance C to F. And then, so if I rearrange, that's where I'm going to get that value from. Okay, so OF is equal to OC, which is 11 units. We were given that. In the question, it's given here, minus the 6 root 2, which we calculated. If you use your calculator, that's going to give you 2.51472 units. Okay, so it means that distance OF is approximately equal to 2.51. And then I must write here that O to E is equal to 7 units, and that reason is because it's the radius. Okay, now I'm going to say, therefore, the tan of E, as discussed, is going to be the opposite, 2.51 divided by the adjacent side, which you've just said is 7 units, divided by 7. I'm just going to keep more decimal points here again, 472. And so it follows that the angle E will be equal to 19.8 degrees. I'm hopeful that you agree that this is a nice question, and it does show that it's a section B kind of question. Again, I hope you had success, and if not, you can always reattempt the question at a later stage. Good luck.